Ever lain awake at night, wondering what the heck quantum electrodynamic is? Well, it's a theory that explains how light and matter interact. And no, it's not the usual fodder for midnight musings. But bear with me, it's just as important, and possibly as entertaining, as understanding why our feline friends have an inexplicable fear of cucumbers. You see, quantum electrodynamic, or QED for short, is the bright spark in the world of quantum physics, illuminating the intricate dance between light and matter. It's like the choreographer of a grand cosmic ballet, dictating every pirouette and grand jeté of particles and photons. But before you run off, scared of highbrow science jargon and complex theories, let me assure you, we're here to make QED a piece of cake. Or at least as digestible as your grandma's fruitcake. So buckle up, folks. We're about to dive headfirst into the world of quantum electrodynamic. Don't worry, no cats or cucumbers involved. Imagine, if you will, a grand cosmic ballroom. It's a place where particles of all sorts, from photons to electrons, come to strut their stuff, each performing their own unique dance move. Yes, you heard it right, dance moves. In this grand spectacle, each particle engages in a fascinating display of quantum choreography that defines their interactions. Let's take the photon, a particle of light, as an example. This party animal is the life of the ballroom. It's like that breakdancer you see at parties, spinning on their head, drawing everyone's attention. But instead of spinning on its head, a photon spins in a way that we like to call polarization. This spin, or polarization, determines how it interacts with other particles in the quantum ballroom. Now let's turn our attention to the electron, the wallflower of the quantum ballroom. But don't let its quiet demeanor fool you. It's got moves that would put even the most seasoned dancers to shame. It spins, but not like a breakdancer. It spins more like a ballet dancer, gracefully twirling around an axis. This spin, in the quantum sense, is not a physical rotation. Rather, it's a property intrinsic to the electron that influences its interactions with other particles. But what happens when these particles collide on the dance floor, you ask? Well, it's not the chaotic mess you might expect from a collision at a regular ballroom. No, siree. It's a beautifully choreographed routine where each particle knows exactly how to move in response to the other. They might exchange a spin or even change their dance moves altogether, but it's all part of the grand spectacle of the quantum dance. So, in our quantum ballroom, every particle has its unique dance move. And when they collide, it's not a chaotic mess, but a beautifully choreographed routine. Ever tried solving a jigsaw puzzle blindfolded? It's quite a challenge, isn't it? Well, quantum electrodynamic, or QED as it's known amongst physics nerds, is like that, but on a cosmic scale. Just imagine each particle interaction is a piece of this giant, invisible jigsaw puzzle. The catch? There's no box with a pretty picture to guide you. It's like you're in a pitch-black room, fumbling around trying to figure out where each piece fits. And just when you think you've got a handle on it, the puzzle morphs and shifts, leaving you back at square one. And that's not even the best part. You see, QED isn't just any ordinary puzzle. It's a puzzle that's constantly changing and evolving. The pieces are in flux, transforming and interacting with each other in ways that would make even the most seasoned puzzle solver's head spin. It's like trying to piece together a puzzle of a chameleon, mid-color change, whilst riding a roller coaster. Now, let's add a dash of humor to this mind-bending scenario. Imagine you're trying to piece together the events of a wild night out from your friends' incoherent stories the next morning. You've got snippets of information, fragments of memories, and a throbbing headache for good measure. The stories are disjointed, the timelines are muddled, and some bits are just plain inexplicable. That's QED for you. It's a puzzle that's not just complex and challenging, but also incredibly fascinating. It's like trying to decipher a secret language or decode a mysterious cipher. The more you delve into it, the more it draws you in. The puzzle pieces might be elusive, and the picture might be ever-changing, but the thrill of the chase and the satisfaction of making sense of the chaos is what makes it all worthwhile. So, quantum electrodynamic is like piecing together a cosmic jigsaw puzzle while nursing a hangover. It's a wild, exhilarating, and slightly disorienting ride, but boy, is it a ride worth taking. Abracadabra, and just like that, particles can disappear and reappear. Welcome to the Quantum Magic Show, where the impossible becomes not only possible, but a regular occurrence. Here, we're not just pulling rabbits out of hats, but particles out of thin air. Let's dive right into the main event. Have you ever heard of quantum tunneling? It's like the world's greatest magic trick, performed by the smallest actors on the biggest stage. Picture this. A particle approaches a barrier that, by all classical physics rules, it should not be able to cross. But in the quantum world, our particle doesn't just stop at the barrier and turn back. Oh no. With a wave of its metaphorical wand and a whispered presto, it disappears from one side and reappears on the other. Now that's what I call a magic trick. But how does it happen, you ask? Well, just like a magician never reveals his secrets, quantum particles keep their cards close to their chest. But we can give it a try. You see, in quantum mechanics, our particle exists as a wave of probabilities rather than a solid point. This wave can extend beyond the barrier, and if the conditions are right, our particle can re-emerge on the other side, as if it had tunneled through. And the best part? This isn't just theoretical mumbo-jumbo. Quantum tunneling is a real phenomenon that has real-world implications. It's the secret behind the operation of many modern devices like flash memory and scanning tunneling microscopes. So next time you see a magician performing a disappearing act, remember this. The best magicians in the world can't hold a candle to the tricks quantum particles can pull off. And unlike our stage performers, these particles don't need smoke and mirrors, just the peculiar laws of the quantum world. So next time you're impressed by a magician's trick, remember, quantum particles did it first. So we've danced with particles, solved a jigsaw puzzle blindfolded, and attended a magic show. What's left? Well, my dear friends, it's time we put on our top hats, take a final spin on the dance floor, and fit the last piece of our quantum jigsaw puzzle. Let's start by reminding ourselves of what quantum electrodynamics is. This is the theory that explains how light and matter interact. And it's like the conductor orchestrating the cosmic ballroom where particles are waltzing around. You remember our dance with particles, right? The one where electrons were the prima ballerinas and photons were the dashing cavaliers. That wasn't just a fun dance-off, it was quantum electrodynamic in action. But it's not just about the dance, it's also an intricate jigsaw puzzle, one that we've been solving blindfolded. Every particle, every force, and every interaction is a piece of this puzzle. It might seem like we're fumbling in the dark, but every piece we add brings us closer to the complete picture. It's like trying to piece together a picture of the Eiffel Tower when you've only ever seen a lamppost. But hey, we're getting there. And then there's the magic show. Quantum electrodynamic pulls rabbits out of hats, makes coins disappear and reappear, and performs tricks that would leave even the most seasoned magician spellbound. But it's not trickery or illusion. It's the real, mind-bending, rule-defying magic of the universe. It's the magician who pulls the strings of reality, and we are merely the awestruck audience. Quantum electrodynamics is vital to our understanding of the universe. It's the theory that helps us understand why the sky is blue, why the grass is green, and why the sun shines. It is the theory that explains the fundamental interactions between light and matter. Yes, it's complex, and yes, it can give you a brainache. But it's also incredibly fascinating. It's the dance of particles, the jigsaw of the universe, and the magic show of reality all rolled into one. It's a realm where particles can be in two places at once, where they can spin in opposite directions simultaneously, and where they can communicate instantaneously over vast distances. And the most remarkable part, all this quantum weirdness is not just happening in some far-off galaxy or in the depths of a black hole. It's happening right here, right now, all around us. It's in the light from your screen reaching your eyes, in the electricity powering your devices, and in the atoms making up your very being. You are part of this cosmic ballroom, this invisible jigsaw, and this greatest magic show. So there you have it, folks. Quantum electrodynamic. It's a cosmic ballroom, an invisible jigsaw, and the greatest magic show you've never seen. And you thought it was just a fancy word for brainache.